Well, I just swiped this up from the front yard of the house that's going to be demolished. And I saw it. I recognized Heathkit. And anything Heathkit, man, it's cool. And it's a regulated power supply. And this is old because, oh, the controls are frozen in it, but that's okay. Because it's got tube rectifiers in it. I'm sure that's what those are. I don't see a number on them. They're Heathkit tubes. But the power rectifiers are tube. So if these transformers are good, this thing's salvageable. This is really cool. And it was just going to go in the garbage. So I can probably look this up. PS4. You know, cool thing about Heathkit stuff is, you know, you can find the schematics and stuff online. So what do we got? Volts and amps probably. What does this go up to? 150 milliamps. And what's our voltage? We go 0 to 150. So that's pretty freaking cool, man. I hope those tubes are good. It looks like they are. The getter is still silver. They're not white. So that's cool. I wonder why it's got two transformers in it, though. I'm going to have to look at this thing and figure this out. This is kind of a cool find. You know, it was just going to get junked. Let's just take a quick look underneath. See a lot of electrolytics. That one's bad. That one's bad. I'm sure that that's bad. I'm sure that's bad. These carbon comps are probably gone up in value. Is this a fuse? It is, and it's missing, but that's okay. I have other fuse holders. We can go around that with a light bulb for right now if we want. Wonder what these are right here. These fuses? I mean, somebody built this, you know, it's a Heathkit, so, you know, you bought it and you made these. Wonder if we can find a date code on one of these caps, maybe? Here we go. 5917. So what's that, 17th week of 1959? So at least that dates the two, but I bet that's it. That would make sense too, because this is not solid state. So, wow, you know, 1959. That is, that's great. Crusty. I have to free up these controls. They're all, well, that one moves. But this one over here in front, this is this voltage adjust? Yeah, output voltage, it's frozen. But we can start that soaking now. I'm just going to take a paintbrush. I already kind of took it to the front here. You know, I like using these. They're real gentle. And, you know, this works real good for cleaning this stuff off. I just hope these transformers, the windings aren't bad in them. But, you know, see how well that works? And it won't hurt anything if you accidentally hit some wires or resistors or components. You know, it won't hurt anything. You know, if you get in here with a vacuum, you know, you're liable to break something. I just carefully dust them and then I vacuum up my mess. I like to clean this stuff up a little bit if I can. Makes a big difference, doesn't it? Oh man, jackpot. This thing's got two 6L6s in it. That is an expensive tube now. Wow, what a find. So I got the wafer switch working. I sprayed it. I've still got to get the I need to spray this. I got the voltage. I think this is B plus output voltage. What is this then? Oh, current output. No, C minus. C minus output. Let's see. 0 to negative 100 volts at 1 milliamp. Oh, okay. All right. B plus, C minus. And then you can switch the meter. And what do you got? 6.3 volts at 4 amps. So this is, they're just drawing off the filament transformer side. And this is B plus output. This is C minus output. I can't get this one to move. This is rusted pretty bad, and I'm just going to very carefully just kind of keep working it and hope that it loosens up. If not, I'll have to figure out what that is. This is way cooler than I thought it was, though. We're going to resurrect this, bring it back to life. This pot is frozen, but it's not open. And across the whole thing, I got 68K, so at least I know what it is. If I go to the center from one side, I don't know which way it's biased right now, but 62, so it's almost all the way up or down. I don't know, I'd have to look at it. So at least I can replace it. So it's just not coming undone. I tried everything too. I've got penetrating oil. I tried a little bit of heat. Just tried working it real easy. I'm going to destroy it if I keep working it like that. So we'll have to replace that. But we'll get it fired up. Let's fire it up and see what happens. It's not going to have an AC line unless I put a fuse in here. So maybe I'll just jump one in with some clip leads. Well, for right now, we'll just put a Chinese clip lead across it. You know, what could go wrong? I'm going to bring it up on a dim bulb anyways, so who cares? Don't know what to expect. You know, we'll bring it up on the Variac, I guess. Probably don't need to, but, you know, if a transformer's bad, you know, these transformers are probably, if that goes, that's going to be the end of this thing. But, you know, who knows? This thing probably hasn't been powered up in 50 years, so let's, without further ado, let's see if we get anything. Yeah, there might be a little bit of current there. 60-watt bulb. Do I have a 25? I do. Let's try a 25 before we get too carried away, huh? Let's try a 25. I don't know what this thing's rated at, so I imagine more than that. I imagine this thing's probably in the 40-watt range, but let's try it. No, there is no current flow there. No way. Not on a 25-watt bulb. So something's open somewhere. Boy, there's not much in between there, is there? You got fuse, that's about it. And it goes straight into the transformer, so I don't know, something open in the transformer. Duh! Helps to put it on. Let's start in standby. That should get us tube filaments, right? I imagine that's what standby is. I'm totally guessing here, but, you know, let's try it, huh? So he's getting the meter out to start metering, you know, where my 110-volt line goes, and I'm looking at it, staring at it, and I go, well, where does that go? I look, and it come around over here while it goes to the back of the switch. So let's start it in standby mode. Let's see here. Well, if there is any current going through there, it's very little, because that's a 25-watt light bulb. Do we have tube filaments? Give it some juice. I don't think that we do. Still don't have anything. So, okay, well, even though I forgot to put the switch on, it's still... Let's get the meter hooked up to it, start checking it. All right, don't ask me what changed because all I did was fidget around with it a little bit. And I just brought it up there. We got 19 volts. I just played with the leads. I was checking the line cord and I wasn't getting anything. I took this clip lead off and went straight to the line cord, and then I was getting voltage. Hook it back up and now we're drawing current. Obviously, we got 25-watt bulb here and it's glowing. You just let it sit for a minute. See if the voltage comes up slowly, and it is. That would be the electrolytics reforming, most likely, or shorting, probably. Wonder if we got tube. Let's see, we're in standby, so we probably only have tube filaments. We can't do too much damage. Let's give it some voltage. It's coming up and it's getting dimmer, so that's likely not reforming capacitors because it's in standby mode. That's probably tube filaments warming up. Let's see, can we see them? Do I feel anything? It's going to be pretty limited. Going to be pretty limited through a 25-watt bulb. Yeah, that's not full brightness for 25 watts, so something should be happening here. We should be getting tube filaments at least. 62 volts. 63. It's very slowly kind of climbing. It's jittery. It's going all over. Hey, we got a light though. We got an indicator telling us that there's power, so I bet this, yep, that totally kills it. So I'm assuming that these tubes are warming up, but I can't feel a thing. They're just dead cold. Oh, that one's warm. So maybe it keeps only one of them warm. Maybe that's part of the standby. Maybe it keeps the 6L6s off. Well, let's just throw it on. Let's see what happens. Let's see, does the bulb go full bright? Yep, sure does. So we've maxed out the bulb. Yeah, now we only got 30 volts now. So that definitely puts something in circuit. Transformers or 6L6s or something like that goes in circuit when you put it full on. We'll let it sit for a little bit, then we'll probably step up to a 60 watter. All right, well, I stepped up to the 60 watt and we're at, I don't know, 60, 70 volts. Let's take it up to like 80. And I hooked up the meter to the, look at that. We're starting to get DC. I hooked the meter up to the DC side. And that's interesting, though. We're getting negative 6.8. And I know I've got the polarity hooked up correctly here. So what is that all about? We're getting some voltage out of it, though. I can't adjust the, maybe I can adjust the B plus output. Oh, yeah. Look at that. I'll be damned. So that goes negative. It actually doesn't go positive till we're like right about there. This thing works. This thing actually freaking works. So we got about 99 volts. So what's it rated to 400? Now I'm going through a 60 watt light bulb at 80 volts, so I don't know exactly what that's going to do to the tube output. Let's take it up. So we're pretty current limited. We're, 60 watt light bulb. We're limited. I got 108 volts DC though. This thing's working. I'm sure it needs capacitors. That's probably why the B plus is so low. I imagine these caps are garbage, just totally shot. But really not a whole lot to resurrect you. Let's see what happens when you go to standby. Definitely kills it. Definitely kills it. This thing works though, and it looks to me like the volt gauge is doing something. Let's see, is it? Yep, it does function. It needs to be calibrated, and I'm sure it's dirty, but I mean, I got 100 and 28 volts B plus. That's just a testament to this American-made stuff. You know, I mean, this is obviously a Heathkit, but you know, it works. I need to find a schematic for this because I really want to see what these two transformers are about here. And I might it might even go up to a 100-watt light bulb here. Here we go with 100. So we're still current limited in case anything shorts. Take it about 80 volts. Yeah, it's barely getting warm. So this thing's somewhere in the 80 to 80 watt range, I guess. But we got B plus out of this bad boy. That's cool. We'll probably do the audio test next. We'll do that on the caps, and we'll see which of these electrolytics are bad. It's pretty obvious though. There's a whole bunch of them that have pooped out, so it's pretty easy to tell with those guys. But this thing's worth fixing. I mean, very, very, very cool find for somebody that was just, you know, throwing it away. Did find a schematic for it last night. Kind of what I suspected. There's a heater voltage transformer, heater transformer over here, and separate transformer for the power side. It does have bridge rectifier in it, some silicon rectifiers, some selenium rectifier. It's interesting that it's got a mix. Here's the two 6L6s. So anyways, I think maybe what we'll do today is probably check the electrolytics, do the audio test on them, and might go through and test the tubes. Some of them were cold last night. I don't know if they were supposed to be or not, just because of the mode that it was in, or what. I haven't quite figured this whole thing out yet, but I will. So I just want to go through and make sure, you know, it's got a standby mode, and these tubes could very well be spent just because somebody left it in standby. It's very possible. So we'll go through and check them. Probably checked out these all the diodes that are in here, and just, you know, get an idea for the general health of this thing. And then we can go through and start replacing stuff. I like to know where these are and kind of where they stand, and run them before I actually start changing parts. The electrolytics, obviously, there's two of them that are leaking, so physically leaked. So they're obviously no good, but, you know, we just want to make sure we don't introduce any problems. We'll start by checking the 6L6s because they're the coolest. And let's see, and D5. Let me double check my setup here. D5 830 and slot 6. Yep. Okay, good, because I already turned it on. So this is emissions. It's getting a little tired, but it's still a good tube. It's still a good tube. And then shorts are what? K4? No shorts. Okay. So, yeah, a little on the tired side, and like I said, it's probably because, most likely because this thing, it's coming up, has standby mode. All right, here's the other 6L6. And she's coming up. It's cold out here, so... This tester, it reads like a new tube is going to be like right around, most of them are right around 65 to 70. Yeah, it's coming up. They're a little tired. They're a little bit tired, but they're good. And let's see, what was it? K4 is K4 shorts. Nope, no grid shorts, so that's good. This tube tester is pretty basic. It doesn't do a lot. Yeah, it's coming up. It's coming up. All right. So the 6L6s are good, though. I mean, they've got, you know, they got something in them. They're not dead, and that's the important thing, because these are one hell of an expensive tube. If you can even get them anymore, I'm not sure. But they're both the original tubes for this. They're both 5917, so that dates this thing. All right. Here's the 6B86. Oh, ain't no problem with that tube. Let's see. What's the shorts on this one? K6. Nope. No shorts. Okay, here's the 6X4. Nothing wrong with that tube. Let's see, 1 and 7? 6X4. 6. 1 and 6. Yep. So those tubes are good. Now it's got some OA2s in it, I think. I've been spraying these sockets too as I've been going through here, working the tube sockets. That might have been why some of these tubes were cold yesterday too. Although those OA2s, I'm not sure. I'm going to have to look at the spec sheet on those because they're not listed in my tube chart. So I don't know. They're some kind of they got to be some kind of a rectifier tube or something. I'll have to look. Similar to like a 3A4 or whatever in a high voltage rectification circuit maybe. So I'm not sure if these are any good, and I can't test them. My tester doesn't list them. So, all right, we know the tubes are all good, or at least most of them. The important ones are good. Maybe on to checking capacitors. All right, just doing a quick audio test here. This is 20 microfarads, and it sounds right. You probably won't be able to hear it, but that's highs, filters off the lows. Come over here. This is a little bit bigger. I can't quite see what it is, maybe 40. And definitely picks up some bass, so it sounds good. Low ESR, no problems. Let's move over here. 70 microfarads, that's about what I'd expect. Highs, most lows. See, that was common, but that's okay. Same thing, sounds good, no problems. They should be replaced if it gets put back into service. They should be replaced. Yeah, that sounds like 20 microfarads to me. Make sure. These capacitors aren't bad. It's not bad. I mean, they need to be replaced, but they're not bad. All right. So I don't even know if I'm going to put caps in this. Maybe someday, but these are dry electrolytics, and I've seen them where they're corroding out like that, and they still work. If I was going to use it regularly, absolutely, I'd recap this, but I don't know that I'm going to use it that often. I mean, how often do I need a 400 volt, 100 milliamp DC power supply? I mean, I guess if I was testing B+ or something on a radio or a TV, maybe. Anyways, we'll leave them for now. They're good. All these silicon diodes right here, they're all good. So we got the nice American-made fuse holder that's missing the cap, which I could probably find one for it. Is this bus? It is. Yep, good quality bus. Replace that with a Chinese one because, it's what I got. 1.5 amp fuse is what the schematic says, so we went ahead and put that in here. It installed real nicely in the hole, so, whatever. So let's check. Let's see. I ordered the pot for it. This is a 50K nonlinear pot. I found a taper pot, which whatever. It's not going to get used enough where I care. So went ahead and did that. Other than that, I'm probably not going to do a whole lot to this thing. I did get the voltage gauge moving as well. Just had to, move it back and forth a few times by hand. I just popped the cover real quick, just very carefully swept it, and it loosened right up. It's working. So I should be able to, let's see, what can I use as a load? Because this is like a high voltage DC power supply. I mean, what the hell am I ever going to use this for? I guess troubleshooting radios, and all the radios I've worked on, I've never needed one of these, but who knows, maybe I'll use it someday. Let's see, I guess I could probably hook up a AA5 to it. It's going to be right on the edge though. This thing's going to be cranking at 150 milliamps at least. All right, so I just hooked up some test leads that I've got to the banana plugs. Here's an old Bendix AA5. Let's turn that on. And I'm going to have to creep up on this real slow because the inrush is just going to make this thing peak. And I really don't want to burn up those 6L6s. So let's see, turn the variac on. It's at full voltage. We're off the bulb now because we got a fuse. Let's see if we get, well, help to turn it on, wouldn't it? So let's watch the gauges here. We should see current, like, oh yeah, look at that. It's turned down. Let's see, whoa, yep. I have to really creep up on it here. So we'll get it up, let it charge the caps, heat the filaments. Actually, it's going to heat the filaments first. That's what the majority of the hit is. And we're just creeping up here. What are we at? We're on the 400 volt scale, so it's about 25 volts. Let's bring her up again. Let's take her close to 150 milliamps. And about 50, 60 volts there. Let's give her just a hair more. We should start hearing something out of this thing very, very shortly. Let's give it just, it should run on about 80 volts, so yeah, we're pushing it right there. We should be hearing something here. Oh, there it goes. There's 1260. The old K Surf, now K Mozart, K no ratings. Wow. That works great. I bet that this, oh yeah, we need to back that off. We're going to burn up those tubes. Let's take it to 100 milliamps. I'm going to freaking red plate the tubes. Oh yeah. So we're down, once you get the filaments conducting, we're down about 50 volts. 50 volts DC. And we're losing it. We're not hot enough. Just not quite hot. There's just not enough power out of this thing, and it's really hard on those tubes, but thought it was a good test. There we go. 125 milliamps at, what's that, 60, 70 volts. Just enough to make it run. But anyways, so if we turn this off here, look at that. Bam. This thing works great. Very, very cool. I mean, for a, what do you want to call it, a street find? I mean, just happened to notice it. It was going to go in the garbage. It was literally sitting on the lawn. You know, it's just rusting away. So, you know, we saved it. This doesn't deserve to get thrown away. I got all this stuff moving here. So we'll get the pot so we can get the C- working. It'll go minus 100 volts at 1 milliamp. What the hell am I ever going to use it for? No clue. But anyways, just a quick look at an old Heathkit PS4. You know, it's all here. I'll have to find some screws for the back, but those are like, you know, 832s or something like that. That shouldn't be a problem. We'll keep it in the test equipment collection. You know, maybe I'll find a use for it. Just a quick update here too. We did get the pot in. I just put a cheap Chinese whatever pot in it. It works. 50K. It's on this scale right here on the bottom because I've got the meter switch over here. Just showing just about 100 volts right there. Let's see, that analog's right about on 100. And we're reading about 102 here on the Fluke. So that's cool. We got the C- working. It'll actually crank all the way up to about 127. But at any rate, it was, in fact, just a bad pot. I mean, this thing is just rusted out.